Hey guys, how are you? Welcome back to the channel. Today is day 45 of upskilling myself, and today I solved two DSA problems as well as did some AWS revision and internship work. So let's see the DSA problems that I solved. So the first problem is letter combinations of a phone number. So we have been given an old phone keypad and we have to, let's say the digits are 2, 3, right? So we have to give the combinations of these two buttons on the keypad, right? So 2 can form A, B, C, and 3 can form D, E, F, right? So we can form A, D, we can form A, A, F, and all that stuff, right? So how to solve it? So first of all, we'll solve it using backtracking as we want all the combinations. So we'll define answer vector, then output string, index, and if the length of the digits is less than 0, we'll return the empty answer. Then we'll map all the digits with the values. So you can see over here we have mapped with all the values. Then we call this backtracking function over here. We pass digits, answer, output, index, and mapping, and then we return the answer. And now in the backtracking function, you can see first of all we have to define the base case. So the base case is that if the index is greater than the length of the digits, then we have to push back the output into the answer, and we have to return. Fine. Now what we have to do is we have been given these digits into a string, so we have to first of all convert into a integer, right? So we'll convert into integer, then we'll get the particular value for that digit from the mapping, then we'll traverse the whole values. Okay, so for int I equals to 0, I should be less than values of length and I will be incremented. Then we'll push back into the output the value, then we will solve, and then we'll backtrack the regular function. We push, we solve, and we backtrack, right? The three pillars of backtracking, right? And then we will get our answer. The second problem is combination sum 2. So we have been given a collection of candidate numbers, candidates, and a target number target. We have to find all the unique combinations in target candidates where the candidate numbers sum to target. Okay, so all unique means backtracking. So each number in the candidates may only be used just once. Okay, so if you remember, we have solved a question where you can repeat the numbers and you can get the target. Here we just have to do one single thing, that is we have to increment this index every time, right? So how to solve it? So first of all we have to sort the candidates, then we'll create a vector of vector int answer, then we'll create an output vector, then we'll define index, we will call the backtracking function, and we'll return the answer. In the backtracking function we'll call candidates, target, answer, output, and index. Okay, so now in the backtracking function the first thing is the base case. So the base case is that if the target is equals to 0, then we'll push back the output in the answer and then we'll return. Okay, and if the target is less than 0, then also we'll return and we'll not do any operation because the target should not be less than 0. Okay, so now we will traverse the array from index to the size and we'll increment I. Now if the I is greater than index and array of I is equals to array of I minus 1, which means the two numbers are same, then we'll continue, we'll skip that. Then if the array of I, if the element is greater than target, we will directly break because the target should be greater than the element or equals to. Then we will push in the output, then we will solve, and then we'll backtrack, right? And after this we'll get our answer. Then for development part, I did some internship work, I did some AWS revision, I mastered some JavaScript concepts, and then did the revision of all the data problems that I solved till now. So thank you guys for watching and see you on day 46.